Hello, folks. So I want to talk through the answers for classwork number 5 on research hypotheses. This first question is asking you to do a little practice with identifying the independent and dependent variables. So the first one says a researcher wants to investigate if males are more likely to get a speeding ticket than females. So here, remember, for identifying the independent and dependent variables, always use that sentence blank influences blank, where that first blank will be your independent variable and the second blank is your dependent variable. So here our independent variable is gender and our dependent variable is getting a speeding ticket or not. We think being male or female, your gender influences getting a speeding ticket. B then is a pharmaceutical company wants to know whether a new depression drug increases suicide risk in teens. So again, ask yourself, blank influences blank. Our independent variable is the drug and the dependent variable is suicide risk. It wouldn't make sense to say, does suicide risk influence taking the drug? No, right? We think that this drug is what's influencing or changing the likelihood of the suicide risk. So remember, the dependent variable is always the thing we're looking at to see, does that change as a result of the independent variable? Does the independent variable influence the dependent variable? Then 2 is having you practice if it's a non-directional or a directional alternative hypothesis. So remember, always, always, always for these, you're always going to have a null hypothesis that is a statement of equality, right? That there's no difference on the dependent variable between groups of the independent variable. The null is always that the two groups are equal. But for the alternative or the research hypothesis, sometimes you'll just have that the two groups are not equal. That's a non-directional alternative hypothesis. Or sometimes you'll have that we think one group is greater than or less than the other. That's a directional alternative or research hypothesis. So this one is just asking you to look at, is it a null hypothesis or a non-directional hypothesis or a directional alternative hypothesis? So this first one says the amount of litter on the streets in Albany is the same as the amount of litter on the streets in Germantown. Here, because we're saying the dependent variable amounts of litter are equal in both groups, the amount of litter in Albany equals the amount of litter in Germantown, that's a null hypothesis, right? The null is always the one that's equal. B says there's a greater amount of litter on the streets in Albany compared to Germantown. Here we're saying that not just is there a difference between groups. Once there's a difference between groups, we know that this is now an alternative hypothesis. But we're also saying that we think one group is greater than or less than the other, right? We think that the amount of litter, the dependent variable, is greater in Albany compared to Germantown. So because there's a difference between groups and we think one group is greater than the other, this is a directional alternative hypothesis. C then says the amount of litter on the streets in Albany is different from the amount of litter on the streets in Germantown. So this one is saying that they're not equal, but we don't have a guess about which one's higher and which one's lower. So because it's not equal, it's an alternative hypothesis. And because we're not saying one's greater than or less than the other, it's a non-directional alternative hypothesis. And it's hard to understand, why do we need to identify now if it's alternative or if it's a non-directional or directional? And the answer is because once we start doing inferential statistics, the type of statistic you use is dependent upon if it's a directional or non-directional alternative hypothesis. So this is just kind of practicing now the groundwork for doing some of the analyses later on, mostly in 302. Okay. Then 3, all of these ones are now having you practice write out the null and alternative hypotheses in statistical notation and in sentence form. So always, as review first, remember for statistical notation, the null is always this H0. We're using the mu, that's a funky little lowercase u. When you're typing it out, just use a regular u. is mu, and there's always the equal sign, equals mu. Mu is our mean, right? And so here we're saying we have to figure out then what goes for each of these groups. A, it says a veterinarian wants to study whether poodles or terriers bark more times in an average hour. She suspects that terriers have a higher number of barks per hour. So first step is to ask yourself, what's the dependent variable? Here we know that the barks per hour is the dependent variable, and the type of dog is the independent variable, right? We think type of dog influences number of barks. So we can always remember that we're comparing the mean on our dependent variable. Oftentimes, here's a helpful trick, that for all of these problems we're doing, the dependent variable is going to be the one that's interval level, and the independent variable is going to be nominal or ordinal, right? We're breaking down the dependent variable to compare the means on an independent variable that is either nominal or ordinal. It breaks into different categories. So here we're saying the null hypothesis is that the mean number of barks per hour for terriers is equal to the mean number of barks per hour for poodles, right? We're making a comparison across the dependent variable for each group of the independent variables. So if you're having trouble figuring out what to put for each of these categories, for each of these groups, know that you always first start by writing out your HO, write out your mu, and then the first thing you write is your dependent variable for each, here barks per hour, and then afterwards how your independent variable breaks down into two groups, right? Terriers and poodles. Once you have it set up as the statistical notation, then it's kind of easy to read that as a sentence, right? That the mean number of barks per hour for terriers is equal to the mean number of barks per hour for poodles. Then your alternative hypothesis, always start by writing out your HA and your X bar. If you want to go through and find like a picture of X bar, or I'm fine with you just writing X bar, write out your HA and your X bar, and your categories, are going to be exactly the same as they are for your null. The categories never change between the null and the alternative hypothesis. The only thing that changes is this sign in the middle. So that once you have your null, the only thing extra you need to do for the alternative is to write HA and X bar instead of the HO and mu, and figure out what is this sign here. So this sign is dependent upon how the research statement is worded. So we know that the alternative hypothesis, you have three choices. It could be does not equal, it could be greater than, or it could be less than, depending on how the research statement or question is worded. Here it says she suspects that terriers have a higher number of barks per hour. So now we know this is a directional alternative hypothesis. We're making a guess about which group is greater than or less than the other. So we say that the mean number of barks per hour for terriers is greater than the mean number of barks per hour for poodles. And so how do you know what this is? This comes from the way the research question is worded. If instead this says didn't have this last sentence at all and just had this first sentence says that she wants to study whether poodles or terriers bark more times, this would be then just a does not equal. That this would be the equal sign with the line through it is a does not equal. Okay, B, a police commissioner wants to know whether using a zero tolerance policing strategy is associated with a lower crime rate than using a hotspots policing strategy. Ask yourself, what's the independent and what are the dependent variable? Here we're saying, does policing strategy, either hotspots or zero tolerance, influence crime rate? So the policing strategy is our independent variable, crime rate is our dependent variable. As always, start set it up for yourself by writing the HO, your mu equals mu. Then you need to figure out what is this category in, or what's this group on each side, right? How, if you were this police commissioner, how would you study this? You would compare the crime rates with using zero policing to the crime rates for using hotspots policing and see if they're equal or not. So set up your two groups, right? Know that you can always write your dependent variable first, here crime rates, and then say, how does the independent variable break down into two groups, zero tolerance versus hotspots? So your null is that the mean crime rates with zero tolerance and hotspots are equal. If it's helpful for you to write out instead more fully, the mean crime rates with zero tolerance policing are equal to mean crime rates with hotspots policing, you can do that too. If it's faster to write just the two of them are equal, I'm fine with that also. Then for your alternative hypothesis, again, nothing changes with your group, right? This, you just copy this down from the null hypothesis. The only thing that changes is you're writing HA or H1, either HA or H1 is fine. X bar changes instead of mu, and then you have to figure out what goes in the middle here. Here, this one says, wants to know whether a zero policing strategy is lower than hotspots. So the police commissioner has already an idea about what strategy is going to be lower. So we know, again, like problem A, this is a directional alternative hypothesis. So we say that the mean crime rates with zero tolerance policing are less than the mean crime rates with hotspots policing. All right, C. I know these are tricky to go through with the steps. That's why we'll do so much practice. And then by the time we're done all of the practice, it's going to feel easier for you. It's going to come more naturally. And I think I explained, I'll say again, like I explained in the lesson, that work on setting up these categories. One of the hardest parts is to figure out what goes for each of these categories, right? If it's helpful for you to think about, okay, if I was this police commissioner doing this study, what would I be comparing? I would be comparing the crime rates for zero tolerance to the crime rates for hotspots. If that's the way that works for you to figure out what your two categories are, do it like that. If instead that's a little overwhelming for you and you want to just think, I'm going to write first what my dependent variable is, and then how my independent variable breaks down into two categories in a kind of more straightforward logical approach, feel free to do it like that too. Work with whatever system works well for you. Okay. C says a bodybuilder wonders if drinking a protein shake or not drinking a protein shake influences his weight in pounds. So here again, ask ourselves, blank influences blank. Our independent variable is drinking the protein shake. The dependent variable is weight. Again, helpful tip or hint, the dependent variable is always going to be interval level because we're comparing the mean for the dependent variable. We can't have a categorical variable for our dependent variable because then we wouldn't be able to be using the comparison of means, right? So if that's helpful for you, know that you're always comparing the mean on the dependent variable, which will be thus interval. All right, so we set up as always our HO, our mu, our dependent variable is weight, and how does our independent variable break down into two groups, with the protein shake and without the protein shake. So the null is always, always, always equal, that the two groups are equal. The mean weights when drinking a protein shake and when not drinking a protein shake are equal. For the alternative hypothesis, writing either H1 or HA, X bar, your group here is exactly the same. And the thing that goes in the middle then is depending upon how this question is worded. Does this say anything about if we think the weight is going to be less or more with a protein shake? It doesn't say. It just says he wonders if drinking it influences his weight. It doesn't say one is greater or less than, so we know this is a non-directional alternative hypothesis. Also, let me give you, this might be useful to see how you put in this does not equal sign. If it lets me do it, my Zoom bar sometimes blocks things here. But if you go to insert in Word and then symbol, it's one of the symbols under symbol is the does not equal sign. Same thing with the, if you ever wanted to use the greater than or less than, and equal to, but we won't use those. Okay. D, car salesman suspects that the average price for a red car is greater than the average price for a non-red car. Here, our independent variable is car color. Our dependent variable is price. We're comparing the price for red cars to price for non-red cars. So our null hypothesis is that the mean prices for red and non-red cars are equal. And then for our alternative hypothesis, we need to figure out what the sign is. Here, this is dependent upon how the question is worded. It says he suspects that the average price for red is greater than the average price for non-red. So that's how we know that the greater than sign goes in here. If instead this question just said a car salesman suspects there might be a difference in prices between red cars and non-red cars, then this would be a non-directional alternative hypothesis, and we would just have the does not equal sign in here instead. Okay, last one, E. This is the fun bonus one because now we have multiple categories. Our independent variable breaks down into 3 categories instead of just 2. So this one is the researcher is wondering if average test scores for students from low, middle, and high socioeconomic statuses are all the same. And I don't know why I have a repeat here of right out the, sorry about that. It's unnecessary additional directions here. So for our null hypothesis, now we're doing this just like the other ones, except now we have 3 groups instead of 2. So here our independent variable is socioeconomic status and our dependent variable is test scores, right? We're asking, does socioeconomic status influence test scores? So we're comparing the mean test scores for people who are low socioeconomic status, middle socioeconomic status, and high socioeconomic status. Our null is always, always, always that all groups are equal. The mean test scores for low socioeconomic status are equal to the mean test scores for middle income students and mean test scores for high SES students. If alternatively you wrote out, or I shouldn't say alternatively, that's confusing for a null. If instead you wrote out the mean test scores for low SES, medium SES, middle SES, and high SES are all equal, that's totally fine as well, just that all groups are equal. Then our alternative hypothesis is that these ones are not equal, that the mean test scores for each group are not equal. There's nothing in this research statement that says we think high or middle or low is going to be greater than or less than the other. The researcher is just wondering if they are all the same. So we know that this is does not equal. Okay, if we want more practice on doing the hypotheses, send me an email, let me know. I'm happy to offer some extra practice ones. If you want to do a live class to do some together, send me an email to let me know that as well. Otherwise, I hope you're feeling confident for the homework. If not, let me know how I can help. And I will talk to you soon. Take care, guys.